Welcome to Lighting 101. This is a class on lighting tools and the trades we're working with. What we want to accomplish here is a little history of lighting, and we're going to get into the tools of the trade, fixtures and lamps, lighting positions. First thing we want to jump to is reflectors. Okay? A little history. If I go back and I put a candle in a room, I'm going to get a sphere of light. The light's going to fill that space. If I put that candle up against the wall, and it's a black wall, well, all the light coming off the back of the candle is going to do nothing. So you've probably seen where people put a candle and a mirror behind it. Well, that mirror reflects all that light and sends it right out. Beginning reflectors. That's what they would do with their bullseye lanterns that you could carry around. You had a lens in it and a candle or an oil lamp and a reflector in it. So what we're going to jump into now is the geometry of reflectors. What I've got over here is a little side view of all the reflectors and how a lamp works with a sphere, parabola, and ellipsoidal. So, spherical reflector works this way. It is not very efficient. Okay? It doesn't direct the rays, it just shoots them back out sort of randomly. A parabolic reflector, however, you can see that any light ray that hits the reflector goes out and it creates a nice shaft of light. Now, the parabolic reflector is used in a lot of outdoor lighting. Can anybody think of a fixture, a really big fixture, that uses a parabolic reflector? Yes. Searchlights use a parabolic reflector. Okay? Notice that all the light rays are parallel. Okay? That'll be important in a minute. An ellipsoidal, if you notice, how do you create if I'm going to draw a circle, and I got a piece of string and a nail and a pencil. I put the nail in the middle, I take the string, and I just draw a circle, right? If I want to make an ellipse, how do I do it?
Two nails.
What?
You have two nails.
Two nails. So the circle has one focal point. An ellipse has two focal points. Notice in our little thing here, we got one, the lamp is at a focal point. Notice all the light goes to this point. That's the other focal point. The focal is a good word to use there because we're going to focus the light. Okay? So all the light from this lamp that hits the reflector gets shot through this focal point and goes out. So we're creating not just a shaft, directed light beam, but we're actually creating an exact image in reverse. Okay? The ellipsoidal allows us to project images. Okay? So if you see a pattern or you see an edge on a fixture, that's going to always be an ellipsoidal reflector. The sphere is used in Fresnels, the parabolic is used in pars. Now, everybody, well, almost everybody in here would remember the show Batman. And they take the searchlight and they want to get Batman, so they put the Batman symbol on the searchlight and you see the bat symbol up in the air. Guess what? That's false. Can't do it. A parabolic does not focus an image. It only does a shaft. Sorry to blow that little thing on your mind. The next thing we've got to deal with is lenses. Okay? And you've got things like the convex, the concave. The plano-convex is used a lot in the ellipsoidal reflector spotlight. Now, back in the mid-1800s, there was a mathematician who solved an issue with trying to focus a shaft, oh, that's where I see it, a big shaft of light. And they wanted to get a lens, and it had to be like 3 foot tall. Well, if you take this big plano-convex lens and you're going to make a shaft, it's going to be a really heavy lens, isn't it? So he came out with, let's cut away this extra stuff and use this. Anybody know what that was designed for first? And there's a clue right in the back of the room. That's what I'm saying. I knew I saw it. Lighthouses. The man's name was Augustin Fresnel. That's where we get the Fresnel lens, the Fresnel fixture name. comes because what he said was, well, I can take this and I can use this and it'll help me focus the light and I can cut away all this extra material and now I've got less weight. I can take these prismatic lenses and they can be shipped from Paris down to the coast where they needed the lighthouses. So that's a Fresnel lens. It is somewhat focused. This step lens was used, but there's no fixture currently available that has this. An ellipsoidal reflector uses this type of, or some do, but most of them they've actually gone to a different style, but it works the same way, that they're coming from the focal point, it hits here, gets bent, goes to this one, gets bent again, and gets refocused in front. So this is where you're getting the ability to project an image. You've got a reflector, a lamp, a set of lenses, and now I can focus an image. Now, and again, this is not something used anymore, but all the older people remember these little things, and you had little devices like this that you dropped in, and you could do a show. What are they? Slide projectors, right? That's an ellipsoidal reflector spotlight. Got to focus the image through a lens. I got to have a lamp. I got to have a reflector. Now, when you had that, how did you put that image in? Upside down and backwards, because what we've been doing is we've been taking the image gets put right, and ignore this, right about here. So it's getting flipped a couple times. So if you take an ellipsoidal reflector spotlight and you put a pattern or a gobo in it, you're going to put it in upside down and backwards. Keep that in mind. So we got lenses. So let's talk about basic fixture types. There are only two basic fixture types. Okay? You have a spot fixture. The other type is a wash. And the basic difference is the ability to focus an image. Okay, so this is an ellipsoidal reflector spotlight. Going back to the days when I started, this is what they looked like. Okay? Nowadays we've got Altman creates the Shakespeare. This is an ETC. Source 4, this is an Altman 360Q. They all have the same thing, that we've got a lamp, a reflector, a set of lenses, and in this portion right here, where you see these little tabs, that's called the gate. Okay? At the gate, you are actually, if you just open up all these, what do you get when you shine it at the stage? A circle, right? You're actually projecting an image. There's a piece of sheet metal right in here at the gate that is a round circle. That's really what's at the gate. You're always projecting. Every time you use an ellipsoidal reflector spotlight, you're projecting an image. You just don't realize it because it's a circle. What you have here are shutters so that in a theatrical production, I can have the person standing at the front of the stage and I can cut the light right 2 inches in front of my feet. It's a sharp edge. No light beyond that. I'm projecting the image of that shutter. Okay? If I put in a pattern in here, I will project the image of the pattern. Okay? So these fixtures are good for where you want tight control or you want to project an image. Like you're doing the Garden of Gethsemane, you want to project leaf patterns so that when somebody walks through it, the light dapples on them. Things like that. That's what the ellipsoidal reflector spotlight is good for. They are more expensive than your wash fixtures. Okay, so take that into account. If you want no light on the curtain over here, you want one of these fixtures. Okay, it's not to say you can't use a wash, but they are less efficient. So typically the other thing about these is they have a longer throw. All right, you can get an ellipsoidal. This says, I can't read that. I think this is a zoom 56 to 40. What you do is you get these lenses. Okay. So we've got the light, it's coming in, it's going to hit the lens, and it's going to produce an angle, right? Okay. In the old Altman 360Q, anybody ever hear of a 6x9, 6x12, 6x16? Trip has. The diameter of the lens was 6 inches. The other number, 9, 12, 16, was the focal length of the lens. Okay. Essentially, what we're creating is a point, and we're creating a triangle. Here's the stage. I can measure this distance. Well, nowadays, a source 4, you're going to get a 5 degree, a 10 degree, a 19 degree, a 26 degree, a 36 degree, 50, I think it's 70 now, and 90. Okay? But that's this arc here. Okay? So if this is 26 degrees, right? And I do a calculation here that this is 40 feet, I can do the math, or I can make myself a little scale triangle, or I can go to the website and I can look at their calculations already, and I'll know that this is, say, 10 feet. Okay? Why is that important to me? Well, one, it's been calculated over numerous years, so you don't have to worry about it, but an acting area with an ellipsoidal is an 8-foot to 10-foot circle at best. Okay? That gets you the right amount of lumens out of the fixture, and that's as much area as you can cover and really control it well. So what you need to do is know this distance, and we'll get into that a little later, but that's where you want to know what the degrees are or the choice. Now, they have zoom ellipsoidals that'll give you a range so you can move the lenses. It's like a, now let me, before I say that, anybody know of another ellipsoidal reflector spotlight that people use a lot? They'll put them in the balconies.
Follow spots.
Follow spots. What are they? They're zoom ellipsoidal because you can adjust how big the circle is, you know, the lens, so you get the size you want, and then you can adjust it with the iris. Same thing. There are zoom ellipsoidals you can get, or you can get fixed degree ellipsoidals. Okay? That's the ellipsoidal reflector spotlight. Any questions about that fixture? It's a very basic tool that we use. Wash fixtures. The Fresnel is a very basic, been used a lot wash fixture. What you've got in a Fresnel is a little portion of a spheroid, but you got this basic box. You've got a Fresnel lens right here, okay? You got a little tray, and on this you've got your little sphere, and here you've got your lamp. This can move. The lamp and reflector can move in relation to the lens. Okay? So that gives you the ability to get a small spot. If it's way at the back, it's going to be a tight spot. If it's towards the front, it's going to be a big spot. I mean, circle. That's your adjustability. Can I focus the image? No. I can never get a sharp edge. It's always going to be a soft edge. So if I want to keep it off that curtain, I'm going to put a device in there called a barn door. Okay? And I can bend these, but I'm going to end up blocking a lot of light. You know, if I turn this on, see, I want to keep it off of the ceiling. I got to bring it. Notice how sharp an edge that is? That isn't very sharp an edge. You know, I want to block. I end up blocking a lot of the light. So, Fresnels are not good for trying. You know, you can barn door Fresnels, and sometimes we do, but the more you get in, then you've reached the point that maybe you got the wrong fixture, because you can take an ellipsoidal and put it out of focus, and you'll get a soft edge. Okay, Fresnels are great because they blend real well. All right, these are tools of the trade. I use Fresnels all the time. Don't think I don't like them, because they just have, I'm trying to get you to understand the differences and the limitations of each fixture. They're great. Wash lights, throw out a lot of color, punch, they can do a great thing. They're soft edge. I like them because, especially like a down light, I want somebody, well, I can put the thing up there, and then it's like a zoom ellipsoidal in a sense. I can create the circle to the size I want. All right, so the one fixture can either be a tight thing, or I can get two people in it. You know, I got a friend here. It depends on what you're trying to do. Fresnels, they come in various sizes. The 3-inch, both of these are 6-inch. This one's just more expensive. This will take 1,000 watts. This thing, I think, only goes to 750. You can get like for these guys, you can get up to 500, 750, and 1,000 watt lamps. Now, if you ever watch the movies, they got these really big ones. They had 10Ks and 5Ks. Still a Fresnel. It was just bigger lamp, bigger lens, you know. Everything was exactly the same.